everyone, welcome back to No's Chem Corner. Today we are continuing the AP Chemistry Basic Series. The things you should know before you are taking the actual AP Chemistry. Definitely this is useful for Honors Chemistry too. The full playlist for the series I am pinning somewhere here so you can check it that one also. Let's get into the video. So in today's video, let's see how we can name the compounds, nomenclature of compounds. Okay, so there is a UPSC like that authorities there. They were telling some rules and regulations for naming the compounds. So we are studying those kind of rules here. Okay, basically we are gonna study three kind of stuff like ionic compounds are there, molecular compounds are there, as well as acids are there. Okay, these are the three set of things. So we need to categorize first whether the compound given compound is ionic or molecular or acids. Then only we can name them. Okay, so first we can study how we are distinguished like ionic compound or molecular compound. Clear? Okay, ionic compounds means metal and non-metals. See, if a compound is formed by metal and non-metal, then you can say it is an ionic compound. So ionic compounds have set of rules, and if it is non-metal and non-metal, there is another set of rules because non-metal compounds are called molecular compound or otherwise called covalent compound. Okay, so for example, see the periodic table. In this periodic table, you can clearly see what are the metals and where you can see metal and where you can see non-metal. Suppose I am telling NaCl. Okay, first you need to categorize whether the compound is ionic or covalent because then only we can use the rules. Okay, because ionic compounds follow some rules, covalent compounds follow some other rules. Okay, then see NaCl. Look at NaCl. Na. See where you can find the Na. Sodium is this one. So sodium is a metal and see the chlorine. Chlorine is a non-metal. So that's why you can say NaCl is an ionic compound. Clear? Similarly, suppose I am telling CO2. CO2. So see where is the C? Carbon is here and oxygen is also here. So which means both are non-metal. If both are non-metal, then that compound is called molecular compound or covalent compound. Okay, did you get the idea? One is ionic compound and the other one is covalent compound. Ionic means ions are there. Ions are there means like cations and anions. Basically metals and non-metal. Okay, metal non-metal combining is ionic. Non-metal is covalent. Okay, once again, zinc chloride, CnCl2. So see the Cn, here is our Cn and chlorine is again here. So metal and non-metal. So what's the compound? Yes, ionic compound. Okay, similarly MgCl2. MgCl2. So that's again magnesium is here and chlorine is here, right? So it's again metal and a non-metal compound. So definitely that compound is also ionic compound. Clear? Okay. Then what about SO2? SO2. So see sulfur. Sulfur is here and oxygen is here. So both are non-metal. So definitely that is also covalent compound. Okay. So that is how we have to categorize them as ionic or covalent. Clear? Okay, I hope you understood. Maybe you may wonder like why I am writing NaCl as NaCl but zinc chloride like ZnCl2. Why it is not NaCl2 or why it is not CnCl, right? That maybe you got confused. Okay, so that's the way of writing the ionic compound. That their formula is also we need to study how to write the formula of ionic compound. Okay, so NaCl like sodium chloride have to name like have to write like NaCl formula. CnCl2 have to be like CnCl2. Why is it so? We will learn. Okay, so first we studied just categorization. How do you know one is ionic compound and the other one is molecular compound? Okay, I hope you understood that part. Okay, now let's move on to the second part. Second part means, as we told, how to write the formula of ionic compound. Okay, how to write the formula of ionic compound. See, According to like the period, the metals are always form positive ions. Okay, metals usually form positive ion. So see their position. Always first group will form positive one. Second group is also metal, they will form positive 2 ion. And group 13, do you see? Group 13 usually form plus 3. Group 14, we didn't write anything. Why, we will tell. And see, 15th group minus 3 and 16th group minus 2 and 17th group is minus 1 and this is 0. Like that the elements are there because that's the most common formed ions of them. Okay. So whenever group 1 elements are there, their charge is positive 1. Clear? And the second group is plus 2. So why these things are like vacant? Why they were not talking about this element, the transition element or the F block element? Why? Because they have multiple oxidation state or charges. Okay. For example, Fe. Fe is also in D block. Fe, when you are talking about Fe can do both 2 plus as well as Fe 3 plus. So multiple states are possible. Okay, so some elements, multiple charges are there, but some elements are some definite charges are there. Like group 1 always form plus 1 ions, group 2 is always form plus 2 ion, and group 3, 13, see plus 3 ion, group 14 also it's different. Group 15 is minus 3, minus 2 and minus 1 like that. Okay, so why we are talking about this? This is how we have to write the formula. Suppose we need to write NaCl, just locate sodium. Sodium. What is the charge sodium? Na is plus 1. So you can write like Na plus 1. And chlorine. Look at the chlorine. What is the charge of chlorine? See, it is Cl and 17th group, which is minus 1. So how do you write the formula of sodium chloride? You just interchange like subscript. Okay, the number, only the numerical you need to take, not the charge. Okay, so how do you write the name of like the formula of this Na sodium chloride? Na and just 1 actually. So if it 1 you don't want to write that one, Na and Cl. Okay, let's see why we are telling zinc chloride. So see, zinc chloride. Zinc is zinc is 2 plus is the charge. Did you see this one? It's 2 plus is the charge. And see the Cl? Cl is again minus 1. So how do you write the formula? This time it is not just CnCl. This time it is CnCl2. Okay, CnCl2. Now do you understood why the 2 where the 2 comes from? It is the charge of zinc. Okay. Then similarly magnesium. When you are writing magnesium, look at the charge of magnesium. Magnesium is again in the second group and chlorine is negative 1. So see Mg2 plus and Cl minus. Then you interchange the charge. Then you will get MgCl2. Okay. What happened? Barium oxide. So how do you write barium and oxide? Oxygen. So see the barium. Barium is second group element and oxygen is minus 2 charge. So how do you write? I can write here. That's maybe easy to see. So see barium is 2 plus and oxygen is 2 minus. So while you interchange, you got Ba2O2. Correct? But simplification is allowed. So you can write BaO. So Ba2O2 is wrong. You can write BaO. Okay. Similarly, suppose if which one is for? Okay, lead. Lead is here, carbon family. So lead can do Pb2 plus as well as Pb4 plus. That's why we didn't show here. Okay. Pb, suppose it is 4 plus and oxygen, lead oxide maybe they were formed. So Pb4 plus and oxygen is 2 minus. So see the formula. Initially you can get Pb2O4, but actual thing is PbO2. Always simplified form you can write. Okay, that's how we need to write the formula of ionic compounds. Okay, right. So this is the way of writing formula of ionic compounds. I hope you understood. Now let's move on to the third part. Third part means how do you name the ionic compounds? Okay. So if it is an ionic compound, this is the way you name the ionic compound. First, always have to write cation. Okay, when you are writing the formula unit, we already write like that way, right? Positive charge we wrote at first. For example, see the NaCl, Na plus and Cl minus, like that we write, right? Which means NaCl. That is the formula. So always cation, positive charged species is what we call cation. Cation have to be the first and then anion be the second. Okay, anion means that negative charged part. So this is positive charged part and this is negative. Positive usually formed by metal and the negative charge is usually formed by non-metal. Okay. So see, these are the rules. So cation, here we already studied, usually group 1, group 2, definite charge is there. But what about this transition element, the D block element? Multiple states are possible, right? So if multiple states are possible, then see the rule. If cation with a definite charge, you just follow like this. Okay, element name and then you can move to the anion name. But the problem is sometimes the cation with a like undefinite charge, like multiple charges are possible. Suppose we are writing iron chloride. Okay, iron, as I told you, FeCl2 is there as well as FeCl, like 2 plus state is there as well as 3 plus state is there. So Fe plus 2 plus state, they can form FeCl2, or Fe plus 3 plus state, they can form Cl3. Okay, so both forms are available. So you need to name differently. So that's why this is the rule. First element name and cation. Roman numeral is applied, like Roman numeral in parenthesis only if the element is multiple states are possible. Element be the cation. Okay, right. And then what is anion? Anion, usually we are telling just atom, right? For example, NaCl. So how do you name the NaCl? IDE. Okay. So NaCl, how do we name? Sodium chloride. Why sodium chloride? Yes, first element and the second element with a IDE. Okay, cation, and then we named anion with a IDE. So here Roman numeral we are not applied. Why? Because sodium we don't have any doubt. If we have doubt, see iron, multiple states are possible. Then you need to write the Roman numeral, which means here iron Roman numeral is needed in parenthesis. So iron in which state? Plus 2 state. FeCl2 means it is plus 2 state. So you need to write the Roman numeral Fe2 chloride. Okay. So that is the name. Chloride. Then what about the other one? Oh, sorry. CHLO. Okay. What about the other one? FeCl3. FeCl3 means iron. So iron is in plus 3 state. So iron Roman numeral 3 is there. Okay. 3 chloride. That is the thing. So Roman numeral is needed only when the element, the cation having multiple states, multiple oxidation state, like the charges. So what are the elements? D block elements, right? See, the elements which is not shown in this list have multiple state. So you can always go with the group 1, group 2, always definite element and definite number is there, and these things are there. Okay, usually D block elements are multiple state, but except silver, zinc, cadmium. So you need to study like that. Usually D block elements are multiple states are possible except these things. So zinc, cadmium, don't want to write the Roman numeral. It's plus 2 always. Silver is plus 1. Okay, right. Then you may noticed one thing. See, anion also can be two type. One we told like this, the element, so you have to name like IDE. Suppose oxygen is given, oxide like that name. Okay, for example, zinc and oxygen combo. So how do you write zinc and oxygen combo? So see, first we can write the formula. Zinc, it is 2 plus state, and oxygen is also 2 minus. So how do you write the formula? CNO, right? So what should be the name? Yes, zinc, and Roman numeral is not needed, and oxide. Okay, like that you can name. Any other doubt? Like suppose selenite. Suppose strontium. Strontium is 2 plus selenium. Selenium is 2 minus oxygen family. So what is that one? Sr Sc. So that is strontium selenite. Selenite. First element no change, same thing. Strontium, and the second element with the IDE. So selenite. Okay, that's how we need to write the ionic compound. But as I told you, anion can be two kind. Okay, so far we are just discussed cation and one anion. That is what we call the binary compound. One cation and one anion, one atom and another atom, just two compound. Like two atoms are there, right? So see, all these things, just two things are right. Sodium and chlorine, fluorine and sorry, iron and chlorine, iron and chlorine, zinc and oxygen. So just two atoms. So that is what you call binary compounds. Okay, like ionic compound, binary ionic compounds. Okay, and another thing is there, polyatomic ion. Suppose the group of atom will play the role of anion or the cation sometimes. Okay, so instead of this kind of chlorine Cl minus, a group of atom may be there. For example, see the group OH minus or NH4 plus. See the cations. See here, not only one single atom plays the role of cation. Here a group of atom, nitrogen and hydrogen is there. A group of atom plays the role of cation, and that thing is called ammonium, right? Ammonium is the only like positive charge they were shown, right? Usually anion is more in polyatomic ion, like we are commonly used to think. Okay, so see NO2 is again a group of atom, not only nitrogen or hydrogen, nitrogen oxygen group is there and having a common charge. Okay, that is what you mean by polyatomic ion. So poly means many, atom means many atom, and ion means charged stuff. Okay, so that's it. So if that plays the role of anion, usually anion. Okay, if cation, then you just name that polyatomic name. Okay, clear? So if, for example, see, instead of I'm again writing NaCl, sodium chloride usually we meant. Suppose this is NH4 plus is there. So same like other one. So how do you name? NH4 having a charge positive and Cl is minus 1. So while you naming the stuff, like the formula is NH4Cl, and what is the name of this NH4Cl? This polyatom have a name. So this polyatomic ion have a name. So use that name. Like here NH4 plus is the polyatomic ion. So you can write ammonium and the same thing, chloride. Okay. Suppose this is the stuff Na, and you can see OH, like Na plus and OH minus. So what should be the name, the formula? The formula is NaOH. So what is this OH? See the polyatomic ion OH here. This is OH minus. OH minus means another polyatomic ion. See, at that time, what is the rule? First element and no need of parenthesis. So just sodium. Okay, and then second element, second atom, like second anion, if it's not an single atom, then you can use their name, like polyatomic name, which means sodium hydroxide. Okay, so that is the thing. See, that's the rule. Now you got the idea. So element name and Roman numeral is needed only if you have a doubt. The element have multiple states are possible. Then only you need the Roman numeral, the parenthesis. Okay, and then anion with the IDE you can use. But if anion is atomic ion, then use the ion name. Okay, that's the rule. Now I think it's clear. So the problem is you need to memorize all this polyatomic ion. Okay, like ammonium. Whenever we are telling ammonium, you should know the knowledge like NH4 plus is ammonium, like that. Aware is needed. Okay, so ammonium is NH4 plus, but it is very easy. I will give a what one thing. Okay, so just study something like ammonium is NH4 plus. You need to study. Carbonate is CO3 2 minus, like that you need to study. NO2, NO3, these are not needed because I will tell that clue. I will tell. Okay, in that way you can study this. So no need to worry about this stuff. And hydroxide you need to study. Acetate definitely you need to study. C2H3O2. The charge also very important. Okay, the charge and the polyatomic ion is needed. Like the name is needed. Okay, cyanide Cn minus is needed. Manganese, permanganate PMNO4 minus is needed. Dichromate Cr2O7 2 minus. Okay, phosphate is not needed. Hydrogen, these things are not needed. And that's all others you can study in another way. Okay, so these things only you need to study. What is the clue for the other? I will tell. Okay, so did you notice something? Like, see the name, NO2 minus nitrite, NO3 minus nitrate, sulfite, sulfate. So it's like ite or ate. So when it comes like ite or ate, which means oxyanion is that. Okay, so you can study like this. Okay, so see, for example, suppose nitrogen is there. Nitrogen forming a compound with oxygen, they will form NO2 minus as well as NO3 minus. So two compounds are available with nitrogen, NO2 minus as well as NO3 minus. Okay, so higher oxygen always tell like 8. Okay, end like 8. Lower oxygen will end like 8. So which means NO2 minus you can write nitrite. Okay, and NO3 minus you can call nitrate. Okay, ATE. 8 means higher oxygen content and 8 means it indicate lower oxygen. Okay, so if nitrogen combo is that one, NO2 minus and NO3 minus. Okay, let's see with the sulfur. Sulfur, two combos again available, but this time SO3 2 minus and SO4 2 minus is available. Okay, it's not SO2 and SO3. So sulfur, one oxygen is added, again one charge is also added. Okay, SO3 2 minus as well as SO4 2 minus. So again lower oxygen is ite. So this one will be sulfide. Okay, this one will be sulfide and the other one will be sulfate. Okay, then now you may got the idea, like you can memorize this thing easily. Okay, what about phosphorus? Phosphorus is also two combos are available, but the same like oxygen combo like sulfur, PO3 as well as PO4. Okay, but charge is again added one. So it's PO3 3 minus and PO4 3 minus. So yeah, definitely you may gust. Yes, phosphite and the other one is phosphate. Okay, right. Okay. Now let's see. Now another important compounds are there. Chlorine, like halogens. Halogens, not only two combo. Okay. Halogens means that 17th group. 17th group means this one. Like chlorine, see this one, 17th group. Chlorine, like fluorine, chlorine, bromine, iodine. These are the halogens. So except fluorine, the others like chlorine, bromine, iodine usually form four combos. Four combos. Okay, so ClO is there with all of them have same charge -1. So you are starting with the 1 is to 1 like ClO and you just add one more oxygen ClO2 -1 and ClO3 having a charge -1 and ClO4 having a charge -1. So see, four combos are available. Now you tell, is it for just chloride, is it sufficient? It's not possible, right? It's not two. So you can just categorize. These two are lower oxygen, right? Okay, so these two are lower oxygen, so we can write chloride. And this is also fluoride. And what about this higher oxygen? That is chlorate. Okay, and this is also chlorate. Now, half of the problem is solved. Now, the problem is what? How do you distinguish this chloride, right? So, what is the name? So, for that, you can use a simple prefix. So, if less oxygen, chloride, right? If very, very less oxygen, you can use a prefix hypo. Okay, so ClO minus is hypochlorite, ClO2 minus is chloride, ClO3 minus is chloride, and yeah, what may be the ClO4 minus? If higher, like higher, like lower oxygen, hypo, like that you may done. So what may be the higher oxygen? You may guess it is hyper, but actually just per only. Okay, if I were on the board, I may be done like that. Okay, okay. So ClO minus is hypochlorite, ClO2 minus is chloride, ClO3 minus is chloride, ClO4 minus is perchlorate. Like that, you can easily study. Okay. Now you can guess what are the names of C, BRO minus, BRO2 minus, because as I told you, except fluorine, all the halogens like chlorine, bromine, iodine have this kind of four combos are available. All of them have same charge and same number of oxygen like this one. Yeah, if you got the idea, you can just comment all the names. Okay, and similarly, IO minus, IO2 minus, and IO3 minus, and IO4 minus. Comment the answers. Okay, right. So, so in this way, see the thing. Now the list is very like lower list, right? So just want to study very few polyatomic ions. All others you can study in this way. Okay, so these are the main polyatomic ions like nitrite, nitrate, sulfate, sulfide, hydrogen, like phosphate, phosphate, like that. Okay, then one more thing is there like hydrogen sulfate or bisulfate. Okay, so see sulfite is SO3 2 minus, then just imagine hydrogen is added. So just add one hydrogen. So hydrogen is H plus. So what should be hydrogen sulfate? HSO3, H plus is actually adding. So 2 minus is not minus 1 actually. So that is what we called hydrogen sulfide. So when with a hydrogen you can just name like that. Whenever hydrogen is added, like another name is there, bisulfite. Okay. Similarly, you can add. Can you write the names of like in comment hydrogen phosphate? What may be the formula of hydrogen phosphate? Right? Okay, let's try with the hydrogen phosphate. So hydrogen is there, so H plus is added. So phosphate, phosphate is PO4 and 3 minus now becomes 2 minus. Okay, another name of hydrogen phosphate, biphosphate. Okay, so in this way you can study these polyatomic ions. This is the easiest method to study the polyatomic ions. Okay, because most of the school will not give the list of this polyatomic ion. They are not allowed in the class. Like if you are doing a honors chemistry, this list maybe they were not given. So you need to study this list. Okay, in this way it may be easier now. Okay, now that's all. Now can you write the name like for example barium? We can write, suppose I am writing barium perbromate. Okay, barium perbromate. So how do you write? Barium means barium, Ba, the formula is Ba2 plus, and perbromate. Perbromate means it is in the list of that four. Do you remember per? So BrO4, the fourth one, O4 minus 1. Okay, so barium formate will be what? Ba, BrO4, and see you can write the parenthesis and 2. Okay, if this polyatomic ion is just 1 in number, don't want to use the parenthesis. Okay, right. Then can you name this one? The next one, can you name? Okay, Pb, mm, NO3, NO3 twice. So PbNO3 twice. Okay, one second. Okay, so see here, how do you name? First one, the cation name, which is lead. Ah, yes, lead nitride. Can I write lead nitrate? So NO3. NO3 means nitrate. Can I write lead nitrate? Ah, which is absolutely wrong. Why? Because lead is not in our list. Lead has multiple oxidation number, like the charge. So you need to write the parenthesis. So lead is in which number, which charge? By seeing the formula, you can tell lead is in which. See the NO3 subscript. NO3 subscript is 2. How this 2 comes? The 2 is comes from the lead, right? Yes. So you can tell lead is actually lead 2 nitrate. Lead is in 2 oxidation state, like 2 charge. So lead 2 nitrate. Okay. But always do not blindly believe the subscript. Okay. For example, if this one is PbO2. Okay. PbO2. So what should be the name? You may tell lead. Okay. And the parenthesis. See, oxygen subscript is 2. So you may tell the oxygen subscript is 2. So the lead is in 2 plus state. That's why the 2 comes there. And oxide, like that you may tell. Right? But what is the problem? What is oxygen oxidation state? What is oxygen charge? Pb, if it is 2 plus, oxygen also has a charge 2 minus. So if Pb is in 2 plus, then what should be the formula? It is PbO. So lead 2 oxide is PbO. This is lead 2 oxide. Okay. Then what about the other one, PbO2? How we can get a PbO2? Where the 2 goes? Because Pb is 4 plus state and oxygen is 2 minus. So see the formula. Now it is Pb2O4, which means C2 and 4 cancel. So that PbO2, like that we got. So PbO2, which means it is not lead 4 oxide, it should be, sorry, lead 2 oxide, it should be lead 4 oxide. Okay. That is the stuff. So that's why I'm telling, do not blindly believe the substrate. Always think about the anion charge. Oxygen, is it really 1 or not? Okay, oxygen, it is minus, like minus 2. So the 2 is not there, which means the simplified version is that one. Simplified version is PbO2, which means lead is in 4 plus state, like that idea you need. Then only we can get the correct formula. Okay, so that's how we need to do with the ionic compounds. Okay, that's all. That's it for today's video. If you found this helpful, give it a thumbs up and share it. Subscribe to Anu's Chem Corner for more videos. I will come back with another basic topic in next video. Bye.